This is Physical Science 2, Chapter 7, Part 1 on the Sun-Moon-Earth system. In this portion of the video lecture, we will be discussing the Earth in space. The Earth's shape is what we call an oblate spheroid. It is roughly spherical. We have mountains, we have valleys, we have trenches, we have plains, but all in all, the Earth is roughly a sphere, which means that all points on the surface of the sphere are the same distance to the center. In ancient observations, Aristotle, this was around the year 2 BC, we have no telescope technology at the time. Basically, observations were done with man's ultimate tool of the eyeballs. Aristotle was one of the first ones to notice way before Isaac Newton and Galilei that objects will fall towards the center of a sphere. Also, when Aristotle would observe a lunar eclipse, that the shadow that was in front of the moon was a curved shape. Also, the fact that the moon itself seemed to be a spherical object in the sky as well. Now, many people believed, of course, that the Earth was flat at the time. However, what Aristotle didn't understand was that people in different parts of the world, which at this point in 2 BC was generally the Mediterranean areas, but people could see different stars above different horizons. So people in the northern part of the world would see different constellations than people in the southern half of the world. If the world was flat and we were all on the same plane, if everyone looked up, everyone would see the same stars in the same position. So that's one of the reasons why Aristotle believed that the Earth was round. We, of course, have everyday evidence of the Earth's shape. We've talked about gravity already. Remember, gravity is the attractive force between two objects, and the larger the mass of that object, the more gravitational attraction it will have, and the closer two objects are, the more gravitational attraction they will have. And basically, in space, where there's microgravity environments, liquids and gases will form in the shape of a sphere, because molecularly speaking, that's the easiest shape for liquid or gas to form in space. Let's talk about some characteristics of the Earth that make it a rather handy-dandy place to live for us. The Earth's magnetic field is an invisible force that protects us from the sun's harmful radiation and what we call the solar wind. Don't think of the solar wind as like a breeze that you could actually feel on your face, but the solar wind is just a very fast streaming set of particles that are not very good for living things like you and I with DNA. So the magnetic field helps protect us from a lot of stuff from space. Where the concentration of Earth's magnetic field is the greatest is at the North and South Pole. However, because the Earth is a very dynamic planet, we do have the actual magnetic locations of the North and South Poles. They actually wander and they change over time. There are dedicated geographic positions for the North and the South Pole, but the actual magnetic North and South Pole will actually wander a little bit over time, and we can, with the help of geologists, try to kind of backtrack the wandering locations of these North and South Poles over time to see how our magnetic field has changed. Another effect of the Earth's magnetic field is what's called the aurora. Remember, the sun gives us light, it gives us heat. It also spits out a lot of really bad particles. A lot of them are charged, and these ejected particles from the sun travel to Earth, and they get caught up in our magnetic field lines. And these little particles will ride the magnetic field lines, and when they do that, they get really super excited about it, and they shake and vibrate, and that causes them to emit light. So these particles collide with all of the atoms in the Earth's atmosphere and our magnetic field and emit light. So in the northern hemisphere, we call this the Aurora borealis. In the southern hemisphere, they call it the Aurora australis. The Earth revolves around the sun in the shape of what's called an ellipse. You can think of an ellipse as like a circle that's been squashed a little bit. It's an elongated circle with two focus points, the sun being one of the focus points and then the Earth being the other focus point. So what this means is that the distance from the sun to the Earth is different during different times of the year because we do not revolve in a perfect circle. And we'll learn later that this distance from the sun to the Earth has nothing to do with how our seasons change. Earth is like I said, a very handy-dandy place for us to live. We are not too close to the sun where we lose our atmosphere. We are not so close to the sun as where all of the liquid water is burning off of the surface. As far as we know, scientifically speaking, we need liquid water for life to evolve. So our location is very handy in the solar system. We have a magnetic field to protect us from lethal solar radiation and wind. So there's a lot of characteristics that make it possible for life to survive on Earth. And it's those characteristics that Earth has that astronomers are looking for in other Earth-like planets in our galaxy and possibly other galaxies beyond. This has been Physical Science 2, Chapter 7, Part 1 on the Sun-Moon-Earth system.